Well, hi guys. We are back for some more oblique triangle stuff, and we're going to study today a specific case that comes up when you're using the law of sines, and we're going to call it the ambiguous case. And it only shows up in one specific type of triangle. Okay, but before we go over this, let's write down what we know, or what we know so far. Okay, so what we know so far is if I am going to try and find some missing sides and angles, and I am given a side, 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 or a side, angle, side triangle, then I am definitely going to use the law of cosines to find my missing sides and missing angles so that I can solve the triangle. If I know, however, an angle, side, angle, or an angle, angle, side triangle, I am going to use the law of sines. Alright, so what we're going to do today is we are going to investigate, what happens if I have an angle, side, side triangle. Anyway, okay. A donkey or something. Anyway, what about this kind of a triangle? Now, we're going to investigate this, and you're going to look at this tomorrow. And I want you to make sure you do every single one of your homework problems. That's one thing that I saw that some of you were frustrated with the equations and for law of sines and law of cosines, and I really don't believe that you practiced them. You didn't do all of your homework problems like I think you should have. So tomorrow in class, make sure you do all of these, because this is a special case, and this needs to ring a bell. Anytime you see an angle, side, side triangle, I don't know what's going on here. Anyway, anytime you see an angle, side, side triangle, that's enough of that. You're going to need to stop, say, hold on a second, this is going to be special, because there's some things that I need to do differently. Alright, so let's take a look at what can happen if you have an angle, side, side triangle. So let me just show you why it's ambiguous. Your geometry teacher wasn't just being silly because they didn't want to make the donkey sound. If you have a set side, and you have a set angle, and you have another set side length. Now I'm going to change my color here to let's do green. The green is going to represent an unknown side length. We don't know this side length, but we do know the purple side lengths, and we also know the purple angle. So this is, I'll go back to purple here. This is known. This is known, and this is also known, but the green will be like an unknown side. The way I have drawn this here, this is an angle, side, side triangle. And you can see that this side length would not make a triangle. And I'm going to show you how to know that whenever you're working the problem, because you won't necessarily be able to draw it to scale, but this would not complete a triangle because it wouldn't connect to the green side. So this would be like a no solution. This will come up whenever we're dealing with that kind of triangle. Another thing that can happen, though, is you can have a known side length, and you can have a known angle, and you can have another known side length that works out to be perfect, and it's okay. It actually completes a triangle. And so this one would be a one solution case. But also it happens that you could have, let me see if I can draw this correctly, you could have a known side length, a known angle, and you could have a third side length that was, that was about this long, that could also be drawn back this way to complete the triangle. So let me draw that. So you could have a known side length in purple, another known side length, but you don't know what angle it extends from this vertex at. You don't know if it comes down this way or if it tries to come back here, making basically an obtuse triangle here. So it will still make triangles, but one of them might be an obtuse angle, one of your unknown angles, and one of the unknown angles might be acute. And this is going to be the two solution case, where you might end up with an obtuse angle in the triangle. So let's just go through some examples to see how this is going to come up. Alright, so I'm going to go back to purple. I'm going to show you an example here. Let's go back to purple, and let's have angle A. I'll just call it angle A here, be 55 degrees. And then I'm going to let the opposite side length be 7 for angle A. So that's side length A. And then I'll let side length C, which is across from angle C, be 25. So we don't know angle B, we don't know angle C, and we don't know side length B. So what we could do here is we could set up the law of sines. The law of sines would say that the sine of 55 degrees over 7 has to equal the sine of angle C over 25. So this doesn't look hard. We can just cross multiply here. 25 times the sine of 55 degrees divided by 7 equals the sine of angle C. So let's go to our calculator and see what that looks like. Let's do 25 times the sine of 55 divided by 7. So 25 times the sine of 55, close parentheses on that 55, and then divide it by 7. What does this give me? 2.925. So I know that 2.925 is the sine of angle C. So what I do to find angle C is I arc sine this. Sarah Kate came to me with this problem today, 6th period, and she told me her calculator wasn't working correctly because she was trying to do stuff like this. Hi, Sarah Kate. Anyway, so if we try and arc sine 2.925, arc sine second answer, some of you might be saying, wait a minute, you can never get an answer that's bigger than 1 or smaller than -1 for sine, so if I try and arc sine 2.9, there might be a problem, and there is a problem. You get this on your calculator. This is your hint to know that this triangle is impossible. In other words, this side just wasn't quite long enough, and therefore, you're too short, bro. Therefore, in this instance, angle C had no solution, so this triangle is impossible. There is no triangle that exists with those specific side lengths. So in that case, your angle side triangle worked out to be no solution. Okay, let's do another one. Okay, let's look at another example where I have angle A to be 55 degrees, and I'm going to let side length A be a lot longer. We'll let it be 27. And I'll have side length C be 25. And let's see what happens here. Let's set up our law of sines. So the sine of 55 degrees over 27 equals the sine of angle C over 25. Now, when we do this on the calculator, we get, and you actually arc sine it, you get an answer for the measure of angle C to be 49.33 degrees. So it works. So you could have this acute angle solution here, 49.33 degrees. So then we could find our other angle by doing 180 minus those two and find the missing angle, and then we could use law of sines again to complete the triangle and solve the triangle and get all three missing angles and all three missing sides. But what you need to look for every time you have an angle side triangle is it possible for that side length 27 to have cut back this way and create the obtuse angle? So in other words, you might remember that whenever we arc sine something, there is another answer. There's another answer in quadrant 2, and the way we get that other answer is we do 180 minus that principal inverse value. So what we're going to look and see is it possible for that 27 to have cut back in this way to create the obtuse angle? Now keep in mind this is still 55 degrees, and when you do 180 minus 49.33, you get, what do you get there? 130.67. And then you need to look at this triangle and be like, could you be a triangle, bro? And the triangle would be, no, I can't be a triangle, bro, because I already have two angles that add together. This angle, this obtuse angle, is too big. So there's nothing left for this third angle. So this only has one solution. Alright, so let's take a look at the next example where angle A is 55 degrees and then across from angle A is 22. And then across from angle C, or side length C, I'll let that be 25. And let's set this up. The sine of 55 degrees over 22 equals the sine of angle C over 25. And when you crisscross multiply and you do the arc sine of something that works out to be less than 1, it works out to be that the measure of angle C is 68.57. So that is one of the solutions. You put 68.57 here. You go ahead and do 180 minus 55 minus 68.57 to find this missing angle B. Go through the law of sines to find the missing side, and you've got that one solution. But then you have to check, is it possible that that 22 cut back in instead of going out to the right to make an obtuse angle? Again, the way you find this obtuse angle is by arc sining that number, and your calculator tells you 68.57, but we should know that there's another possibility. That's the one that's in quadrant 2. So we do 180 minus 68.57, and we get that that's 111.43. And then we have to look and see, is this triangle viable? Is there enough left for the third angle? And if you add 55 and 111.43, you get what, 166.43. So there is still an angle left for that missing angle up there, and that's 13.57. This one works out to have two solutions: the regular solution, 68.57 degrees, but then also the obtuse angle, because there was enough left for that third angle. So I would then have to have this side is 22, this side is 25, and now I have a different answer for angle C, and then I would have to subtract that from 180. I found angle B, and then across from angle B is my side B. So this one works out to be two solutions. And you again, I really encourage you to practice this tomorrow, and not just come in and be like, oh, I'll just use the law of sines sometimes and then maybe subtract something from 180. But anyway, so whenever you see angle side side, you have got to check these three possibilities. I'll see you tomorrow.